Hello folks, and welcome back to the Tesla project. So today we are looking at the version 2 logic board for the large drive unit. So what you may remember if you've been following the series is we designed a board and tested it in the large drive unit inverter. We had several problems with that board because I'd made some mistakes in the initial reverse engineering, particularly of the current sensors. So we went ahead then and we took the lessons that we learned from that design and produced this one. So the bare PCBs turned up, and what I've done here now over the last few days has just been to fully populate one of these boards by hand. Bit of a job, but did it nonetheless before we kind of start getting any of them professionally made. And we've just been doing some bench tests here now today, and I'm very pleased to announce that so far things look to be working out quite well. So let's go have a look and I'll show you guys what we've got going on so far. Alright, so over here on the bench we've our large drive unit inverter. We have our new logic board fitted here. Again, it's the same footprint, mountings, the whole lot of the original Tesla board. Excuse me. And so we've got everything plugged in that we need to run it. You can see a little blinking green LED here telling us that we have a working processor. So a lot of the changes that we made, again, they've been covered in a previous video. I'll put a link in the description to that. But we've got our new current sensor measurement circuit going on. And one of the other changes that I made is I put a jumper header here to allow us to use either CAN or RS-232 for external communication. So you just change the position of those jumpers. They're on RS-232. If you move them to this side, you get CAN. And the firmware that we have on here at the minute actually does implement the CAN open protocol, so you can communicate with CAN. And that'll be something we'll be covering in a later video. So at the minute, we're pretty much set up here just with my little 1 horsepower industrial test motor. And so we'll go ahead now. And I'll just show you guys that motor spinning here. Got my RS-232 coming out through the cable loom, just down to a little DB9 here, and a converter going back to the laptop. So right, I'm going to get the power turned on. We'll show you guys the motor spinning here next. Alrighty, so we should be ready to go at that. There it is. So this is basic open loop mode now. We are pretty much just running our inverter at 10 Hertz just out into the into our little test motor here. Now, couple of interesting things here just on the computer just while we're running is that we can actually now get a valid current readings from the current sensors, and additionally we are able to maintain RS-232 communication even when the inverter is running. So that's kind of pretty important. So that's kind of it for the initial bench test. You know, we've got this motor running. We're kind of proving that our logic board is doing what it needs to do here. So, okay, next part of the plan for today is going to strip this down, get this guy outside, and let's see if we can run the actual Tesla motor from it. Alrighty folks, so we are out in the workshop here. I've been doing a few tests now with the inverter and the large drive unit and the V2 board. I'm very pleased to say that it is pretty much working as advertised. I'll show you guys now in a minute what we've got going on. It'll be a fairly familiar setup for those of you that have been following along with the series. But basically what we've managed to do today is, with our new board, it's pretty much plug and play. There's been no real need to modify the circuit at all. It's just pretty much running the motor as expected. And very big thing is it is reading the sigma delta current sensors perfectly now. And I've actually calibrated it against my fluke meter here, which I'll show you in a minute. And the current limit shutdown is now working as advertised as well, as are the DSAT detectors on the Tesla IGBT driver. So yeah, this one is very, very close, guys. So let's go have a look at what we've got going on. So it's pretty much the standard setup here. I have my large drive unit connected with some flying leads to the large drive unit inverter. Got a good quality AC current clamp there on one of my phase leads. Two DC power supplies. One of them is providing about 14 volts for the logic, and one's providing about 45 volts to run the DC bus. We've got our laptop set up. Our RS232 is working away beautifully. We've not having any problems with FTDI chips or leads dropping out. We can run plots and the whole lot here with this. So far now, you know, fair enough, it's low voltage. We're pushing maybe 50-60 amps per phase at the minute, so it's not definitive, and kind of won't be until I get on to the high voltage stuff. But anyway, basically, let's get a quick look here for you guys. So basically, this is a plot that I've just ran the motor there a few minutes ago with our current sensors, and as you can see, not only are they reading very close together as they should, but they're reading quite accurately against the fluke meter as well. So we're set up in forward mode here. I've got my E46 throttle pedal, and all I have to do really is to just push on the throttle, and our motor starts moving. Can lean on it a little bit. Just got limited power available there from the power supply, but you know, it's just enough to run it. And I've got Regen disabled as before because we don't have anywhere to put the Regen power at the minute, because we're just using a power supply. When we switch over to using battery, we'll be able to use Regen. So that's forward. We can change around our wires here. I'm going to have to make a little control panel as well. We put the reverse wire in there, and again we'll see our motor will run in reverse. There we go. So all the functions, you know, cruise control, brake input, all that stuff's working away as well. So let's go back to forward, and I'll just show you guys a little plot of the current sensors there. So I've got to put the offset in as well, because they're kind of reading a little bit high at zero there. They're reading about, you know, 1 amp or so. So if I push my throttle now, we can see there's about 35 amps on the meter now, and there it is. It's plotting the current per phase there very, very well indeed. 25, so it'll start to, you'll see the current, you know, as the motor speeds up, the current will reduce a little bit, and you'll see that on the graph here as well. And just go back to 0, and the motor will just coast down. And you'll see there that we've pretty much, you know, pretty much got the current sensors working here now. Keeping in mind as well that we're only clocking them at 4.6 megahertz right now. Tesla clocked them at about 18 megahertz, so we certainly have more accuracy that we can get there if we need to do so. So that's kind of the bench setup at the minute, guys. Yeah, very big deal this, that this board is pretty much just working out of the box for me. So right, okay, that's the test setup so far. Okay folks, so this is us with high voltage on the bus. We're at 360 volts at the minute. Still got Regen disabled. And we've taken our current limit up to 200 amps now. Oh, obviously I've been a little bit too conservative with my current limit. That's okay. I'd rather be too safe than too sorry. Tends to accelerate rather rapidly. You can see the current spikes here. So okay, that's let's try for 300 amps. Just have to be particularly cautious here because I've no cooling on the inverter, so that's really where my worry is at the minute. There we go. Alrighty folks, so I have some regen values dialed in here. A couple of things I had to play with on the parameter front, but we pretty much got ourselves running here now reasonably well. It's a little bit jerky still on the throttle, but let's go ahead and have a quick look. Regen down, ramp up, and regen down. We're getting about 120 amps per phase on the regen there, and about 100 amps on the acceleration peak current. So let's bring you guys in a little bit closer here. As well go for the old close-up. Back down, we got 120 amps of peak there. Accelerating up to 150 amps that time. And regenerating back down, we got 140. So there we are, guys. Not too bad. Alrighty. I hope you guys enjoyed that. It's pretty amazing first test of our version 2 prototype board here for the large drive unit. Running on high voltage for the first time. current sensors working and calibrated, overcurrent limit working and calibrated. Yeah, pretty much most everything working. RS-232 working. I haven't tested CAN yet, but you know, that should be fairly straightforward. So that's about it for today, guys. Pretty major milestone by the same token. You know, the next part of the puzzle now will be basically putting the inverter back into the drive unit, bolting everything back up, and then I need to start working on calibrating the temperature sensors. Then we'll run some coolant through this thing, and we can do longer duration runs here. So that's about it. I'm just kind of, yeah, I don't even know what to say. I'm just so excited about that now. It's just amazing to have that working with only 2 iterations of the PCB design. So, obviously links to that design are on my GitHub and will be in the description. Also, if you like what I'm doing and you want to support me, then please see a link in the description to my Patreon, where you can make a financial contribution. If you'd rather not use Patreon, there will also be a link in the description to my PayPal email address. donations@evbmw.com if you would prefer to use that method. Anyway, don't forget to subscribe and leave a like, and we will be back very soon with some more Tesla mayhem, and also getting close to putting this drive unit into the Panzer. So that's it for today, guys. Happy prototype PCB testing.